All right, recorded is rolling. It is Monday, September 12th, and we're gonna finally do this projectile lab that I've been wanting to get to for a while. And that'll wrap up kinematic motion today. So get one last look at the. Here's top scientist for linear motion. You guys heard this quiz in last week. I do have this quiz back in your folder. So we're gonna get up here in a few minutes. But when we do, at some point, you'll probably find a good chance to go back to your folders. You can find your quiz, get that. Yeah. So if your name's up here, you're a top scientist. You're super awesome. So yeah, way to go. Let's do this. Yeah. Quiz to return to folders. If you want partial credit back, then if you find all the problems that you missed and you handwrite corrections and turn those into the grade tray, then I'll give you partial credit back. Okay. So if you there's like one question, so you got a 90 and you handwrite corrections back, then well, you get like a third of that back. If you got like a 70, you handwrite corrections for the three problems you missed, then well, you get a third of that back. Right. Right. So okay. Get some back. Also speaking of corrections, I posted corrections to Google Classroom. Actually, they're slated. They're after school today. They're going to pop up there. Okay, so at the end of the school today, they're going to pop up on Google Classroom. So you can reference those and see like exactly how to get to each answer. Okay. All right. All right. So a bunch of guys just turned in your projectile homework. So thank you for that. I will check that off, and then yeah, some of you guys had questions about like even the solutions, like why did I do this or that step in the solution? So those are always good questions. Yeah, you go to the before after school about those, or possibly even when we're out here during the lab, if you have a quick question about like how did this or that work, then those solutions are on your desk. The packets are, so if you really had a pressing question, then I want to look out there, right? All right, and then your guys' projectile take-home quiz, that's due tomorrow. So you guys had a few days to do that. You guys get one more day there, right? So today, yeah, we're finally going to do this launch lab, and then tomorrow we're going to go into forces. I do have your guys' next homework up and ready to go. I'll give you guys the tape first tomorrow, so we can just focus on the projectile lab today. But if you wanted a sneak preview, then all that stuff has been uploaded to Google Classroom for a few days now. Okay. All right, so. Here's the question I've got for you guys is what is the launch speed of this launcher? Wow, this is from you guys. All right, so demoed this to you guys back last week, so you guys had a few days to sort of think about this, but you guys remember there's this launcher, remember spring loaded, you can take this ramrod, right, ram it, and then there should be a ball on your desk, you put this in here, and then you lift this, it goes, and out it fires, right? That releases it, right? You can change the angle if you want to, and there's this bob with the built-in protractor. It tells you exactly what angle it's at relative to the horizontal. Okay, you guys get that? Right now, let me tell you guys a little bit about the mechanics of the ball. There are two different kinds of balls. If you have a hard yellow one, it's like pretty much exactly 10 grams. If you have kind of a squishy, bouncy ball, call it 6.4 grams. Okay. Now, good. Let me tell you, really important, just like technical mechanical thing, like to do or not to do. If you take especially the squishy, bouncy ones, and put the bouncy one in first, and then take the ramrod and stuff it in after the fact, you're gonna be spending all day trying to get the squishy, bouncy ball out. So yeah, if you want to have that kind of fun today, but most of you guys probably want to be launching these things, and that's probably a lot more fun. So. What you should do is like ramrod it first and then put the ball in afterwards. Okay. Okay. So guys, what are you going to do first? You're going to stuff in the ball first and then ramrod it? Or you're going to ramrod it and then stuff in the ball? Yeah, use the rod first and then stuff in the ball. Okay. Right. All right. So the question that I'm throwing at you guys is what is the launch speed of this launcher? Now, there's different setups you can go about trying to figure this out. So I've sketched up 3 different pictures, like 3 different ways that you could set this up. I'm gonna let you figure out with your teammates which one you want to do. Actually, we're gonna take a few minutes before we go outside. You guys have paper out, right? You guys have paper? Hey, if you don't have any paper, got a whole stack right here. So I'm gonna have you guys make a table. Now, what's gonna be on your table? That's one of the problems I'm gonna leave up to you and your classmates to figure out, like, well, what data should we record? Okay, but maybe I'll give you guys a few hints. I mean, there is a built-in protractor here that may or may not be helpful depending on what setup you go with. I did go ahead and give you the master ball just to save everybody a little bit of time because we have the limited time. Oh, do you guys have a meter stick on your desk? Meter stick on your desk? That might be good at measuring, right? Some kind of displacement. I think vertical and horizontal displacement, depending on which setup you go with. How about I have one of these. I guess it's called a trundle wheel, right? So it has exactly a 1 meter circumference. So you can roll it across and then measure displacement that way. I'll put this, let's say right here. So if you want that, I have one of those. And also on every single desk, I do have a speed gate, one of these speed sensors. To tell you what, sometimes AP will give you a prompt, something along the lines of saying like, if you don't have one of these. So let's say you don't have one of these, but if you want to use it just to say, check your answer just for fun, if you want to like put it right here and try to grab the speed that way, you can't for fun, but let's say theoretically you don't have it for the lab, okay? But if you want to take it out there for fun and see, like, check your answer, okay? All right, so in your lab write-up, you're not going to mention the speed sensor, right? Okay. All right, so no speed sensor in your lab write-up. All right, so let's do the classic AP write-up. Remember, you guys are going to get an FRQ in May. This is all in preparation for that. And the lab write-up FRQ, it always follows the same format. It's exactly this format. Okay. I do have the launchers. I'm gonna use them today.
Don't worry about it.
Yeah. All right. Ooh. All right. Well, I have them for you guys. How about that? All right. So there's part one is the question, but we're all getting the same question, right? Is what is the launch speed of the launcher? Okay. You need to list what measuring tools you're using. Now, what measuring tools you use, I'm gonna leave it up to you and your teammates. Right, I showed you guys a few measuring tools. Just don't say the speed sensor. Just leave that one off the list. I forgot to mention stopwatch. If you want stopwatch, you might not even need stopwatch, but hey, if you want to incorporate that somehow. Okay. Procedure. Now, what AP is looking for the procedure is always which variables you're measuring using which measuring tools. So if you said meter stick, then somewhere in the procedure say what you're measuring with the meter stick, right? Are you measuring a vertical displacement, a horizontal displacement? Did you say a protractor? Are you measuring some kind of launch angle? Did you say stopwatch? Right. So, right. Remember your measuring tools are going to tell you like what steps are going to be involved in your procedure. Okay. What are you measuring? Okay. Step 4, analysis. So, how are you taking the variables that you measure that you probably put in a table, right? So you guys are constructing a table, right, with different variables. Right? Right. So how are you going to tie this back to equations or graphs? And you might use equations or graphs, depending on exactly how you want to purchase to answer the question: what is the launch speed of the launcher? And your conclusion, guys, what unit should your conclusion have? What units? Meters per second, right? So at the end of the day, you should have some number of meters per second, right? Okay. Oh, are you allowed to know what free fall gravity is on Earth? Yeah.
No.
So you're allowed to know that you can call it 9.8 meters per second squared. You can call it 10 meters per second squared. Either way, it's not going to make that much difference. Okay. All right. You guys good with that premise? All right. So I'm going to give you guys a couple minutes to come up with a plan with your teammates, draw a table, maybe start sketching up the spy part write-up. We're going to come back in by the end of class today. And if we have time, then actually, I'll flash it up here real fast. I have an AP style rubric to score points for you guys, depending on exactly what your setup is and how you go about it. Right. So I'll have you guys grade yourselves according to the rubric. And there we go. All right. So let me go ahead and stop this recording and give you guys a couple minutes to come up with a plan with your teammates.